All right, we are covering 4-5 triangle congruence, angle side angle, angle angle side, and hypotenuse leg. Remember to take something to take notes with and complete the check it out problems.
We have two learning targets today. The first one, I can prove triangles congruent by using angle side angle, angle side, and hypotenuse leg. And I can apply angle side angle, angle side, and hypotenuse leg to construct triangles and to solve problems. I actually won't be covering that in this lesson.
Aren't you lucky? All right, we have a few vocabulary words that we need to remember. Included side, it's kind of like included angle, so you probably don't remember this because we haven't covered it yet, but we did cover included angle. So it's the side between two consecutive angles. So in this case, PQ would be the included side in between angles P and Q. We also have a postulate, and this is another way to prove triangle congruence, angle side angle. So if two angles and the included side, so it's very specific. You have to have the included side. If they are all congruent to two angles and the included side of the other triangle, then the triangles are congruent by angle side angle.
So here's our first example. Determine if you can use angle side angle to prove the triangles are congruent. So right now we have angle. We have two angles and two angles are congruent. Do we know anything else? We know this side is congruent to itself. But looking at this, do we have enough information to go angle, side, angle? The included side is not, so this answer would be no. Not enough information for angle, side, angle. If we knew that this side and this side were congruent, these would be the included sides, but we don't know those are congruent.
All right, you're going to try this check it out problem. You're going to determine if you can use angle side angle to prove triangle NKL is congruent to triangle LMN. Good luck.
Okay, here's another theorem we can use to prove triangles are congruent. It's the angle side or angle side. You can abbreviate that using AAS. And that states if you have two angles and a non-included side of one triangle are congruent to the corresponding angles, a non-included side of another triangle, then the triangles are congruent. So we have angle G, angle J, and side JH is congruent to angle, or to triangle KM and side ML. So therefore, those two triangles are congruent. And here's just a proof if you want to figure out how angle side congruence works. So you can review that proof at your leisure.
All right, so we're going to use angle side to prove the triangle is congruent. Let's look at what they've shown us first and then look at what we're trying to prove. So it says angle X, oops, that's weight. Angle X is congruent to angle V. Angle YZW, so YZW is going to be this angle, is congruent to YWZ. YWZ is this angle, so I need 2 on those. And then XY is congruent to VY. And they want us to prove that triangle XYZ, so that's this triangle here, is congruent to triangle VYW. All right, so I've written the steps for the proof. First, we're given angle X is congruent to V. We're also given that angle YZW is congruent to YWZ. And 2, we know that angle YZX, so this angle here, this angle here, and this angle here, they're supplementary to the angles on the other side. Hopefully you can see that. And because they're linear pairs, these two angles make a line and these two angles make a line. And because they're supplementary to congruent angles, we know that these two angles are congruent. I hate that color red. Sorry. Change color to something better. Something better. There we go. So those two angles are congruent. Why? Because they're congruent. They're supplementary to two congruent angles. So we had a theorem called Congruent Supplements Theorem that tells us that those two angles have to be congruent as well. We're also told that xy and vy are congruent. So now we know these two triangles are congruent by angle, side.
Okay, now it's your turn for your checkout. Again, using angle, side to prove those two triangles are congruent. Triangle JKL is congruent to triangle JML.
All right, and this is our last theorem for proving triangle congruence. It's hypotenuse leg. It says if the hypotenuse and the leg of right triangle, so this only works if it's a right triangle. If the hypotenuse and the leg of the right triangle are congruent between two triangles, then the triangles are also congruent. So in this case, we just have to have two of the sides being congruent, specifically one of the legs and the hypotenuse, and it has to be a right triangle.
Okay, so we have two examples here. We want to determine if hypotenuse leg congruence theorem will work on these two triangles congruent. So our first one we're going to look at, for A, first of all, we have right triangle, so we can use hypotenuse leg. And looking at this, our hypotenuses are both congruent. Hypoteni. But we know that the side that they share, the leg that they share, has congruent to itself, so we can use hypotenuse leg to prove this congruent. So yes, hypotenuse leg works for this one. Now let's look over at B. Again, we have right triangle, so that's the first start. We can look at using hypotenuse leg. We only have markings here for one side being congruent, or one leg being congruent. We don't know about the hypotenuse. So in this case, we have to say no. We can't use hypotenuse leg to prove congruence. We don't have enough information. We'd have to know the hypotenuses. If these were marked as congruent, then we'd be good to go. But they're not, so we can't.
All right, so here's your check it out example. You will look at these two triangles, ABC and DCB, and see if you can use hypotenuse leg to prove that they're congruent.
Okay, so to summarize all this, we have a few things here. Right now we looked at three ways to prove triangles are congruent. Angle, side, angle, which you have to have the included side. Angle, angle, side. And hypotenuse leg, and for hypotenuse leg you must have right triangles to look at. And we've been telling you this most of the year. When you're starting with, when you're doing a proof, mark the given information on your diagram. If there isn't one there, draw one out. It's going to help you with your proof. And a nice little thing also, since you're using angle, side, angle, 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 side, as you're going through your proof, if you have the sides being congruent, mark that. Angles being congruent, mark that. You can see which one is, do you have enough information to prove congruency. And then make sure that the included angle is named by the two vertices of the angle. It's named. Oh, it should be named. A little typo there.
I was going to say that didn't make sense.
It did, but it does if we fix typo. So if you have questions, bring them to class, and good luck.